A linked list is a common data structure where elements are stored in a node. The node contains two key pieces of information: the element itself and a reference to the next node. So in this example, the element here would be 1, and then here's the reference to the next node. This arrow is pointing to the 2. This 2 is the element we're storing the information to, and then we have this link linking to the next node. Like arrays, linked lists can be used to implement many other data structures. Linked lists have some advantages and disadvantages when compared to arrays. Traditionally, arrays just have a fixed size, and linked lists have dynamic size. So you can just keep adding links and you don't have to do anything differently. JavaScript kind of hides some of this, but when you create an array, it can only be a fixed size. Also, arrays have pretty inefficient insertions and deletions, while linked lists are very efficient insertions and deletions. A benefit to arrays are the random access, which means you can say you want something at index 5 and you can instantly get the thing at index 5. However, with linked lists, if you want something at index 5, you have to go through every element in the linked list to get to index 5. And then for arrays, they may result in much memory waste. To make up for the fact that arrays can only be made at a fixed size, sometimes they will be created a lot bigger than what you really need to make sure you have enough room for everything. However, in a linked list, because of the dynamic size, there is no wasted memory. And then we have really fast sequential access for arrays and slow for linked lists. So every linked list is going to have a head. So we have this head pointer here that points to the first node. And then it's also going to have a size. So that's just the amount of nodes. So in this example here, the size will be 3. And you can see each node points to the next node, and the last node just points to null, because there's no next node. So if you look at the code over here, we start with a head of null because we don't have a head yet, and the length is going to be 0. And the linked list is made up of nodes. So here's how we're going to create a node. We pass in an element, and this dot element is set to element. This dot next is set to null. So this dot element in the picture is the info, and this dot next in the picture is the link. So it starts off just like the last element where the link is pointing to null, next is pointing to null. Then we just have a few simple functions. This dot size just returns the length, and this dot head just returns the head. And here's the add function. Whatever we're going to pass in to the linked list is going to be the element. So you're going to add the element, and then we're going to create a new node with that element. So after you pass in the element and it creates this new node, the element of the node is set to the element you passed in, but the next of the node is set to null. So if head equals null, that means there are no nodes in the linked list yet. So we just set the head to equal the node. And at that point there would just be one node in the linked list, and the head would be pointing to that first node. Else, that means there's more than one element in the list. We're going to set the current node to equal the head. And let's add a var in front of here. So this just means that we're going to start at the head node, which you always have to do. Whenever you're doing anything to a linked list, you start at the beginning and then you have to go through each item in the list. While current node.next, that means while there is a current node.next, while current node.next does not equal null, you can see at the end, remember the link equals current node.next. So at the end, it equals null. So before the end of the list, the current node.next, which would be the link, does not equal null. It equals the next node. So this just means while there is a next node, current node equals current node.next. So that's just a way to hop from node to node on the list. Once there is no current node.next, that means we're at the end of the list. The end of the list is where we want to add the element that we're adding. Now we'll set current node.next to equal the node. Once we get to the last node in the list, we'll set the current node.next, or this link, to equal the new node we added instead of null. And we just increment the length. The remove method takes an element and searches the linked list to find and remove the node containing that element. So you're passing the element that you want to remove, and we always start at the head, current node equals head, and then we also need to know the previous node when you're going to remove something. So if the current node.element equals element, if current node.element equals element, well, that just means that the head node is the element we're trying to remove. So if we're trying to remove the head node, we just have to set the head to current node.next. So the head pointer will be pointing to the next node. If the head node is not the node we're looking for, we go to the else. So else, while current node.element does not equal element, basically while the node we're on does not equal the node we're searching for, previous node is going to equal the current node. Like I said, we have to keep track of the previous node, and then the current node is going to equal current node.next, which just means we're going to keep going through this while loop and keep jumping to the next node on the list until we find the node we're looking for. Let's say it's the second node on this example here. We're going to set previous node.next to equal current node.next. If we're trying to remove this second node, we're going to set previous node.next. So the previous node.next would be the first node. So that would be the link. The link is now going to not point to the current node. The link is going to point to the current node.next. We would skip over that node and point to the current node.next right here. And that's how a node would be deleted from the linked list. And then we just decrement the link. Now here's another quick function, is empty, return linked equals 0. So if the length equals 0, we're going to return true. If it doesn't equal 0, we're going to return false. And you may want to know the index of a specific element. So we're just going to have to hop from node to node until we find that element and then return that index. So the current node is going to equal head, start at the beginning. Index is going to start at -1. And so while current node, that means while there is a current node, while it's not null, we're going to increment the index. So at this point, if we start at the beginning, we've incremented the index, so where the index is now a 0. So if current node.element equals element, return index. So if the first element, which would be this info, equals what we passed in up here, we're going to return the index. So if instead of the head node, we're going to return the index 0. If not, current node equals current node.next, and then we're going to continue doing this while loop and just hop from node to node, and then we're going to eventually be able to return the index as we keep adding 1 to the index for every time we do the while loop. And if we go through all the whole while loop and don't find anything, we're going to return -1. That just means the element is not in the linked list. So we just found the index of an element. Now we're going to find the element at an index. That's just the opposite. You're passing in an index number and you're going to return the element. So we have current node equals head, count equals 0, and here's the while loop here. While count is less than index, that means we haven't gotten to the index we're searching for. Increment count, and current node equals current node.next. So that means we hop to the next node. So we're going to keep going through every node in the list until count is not less than index. That means count equals index. So we've reached the right index. So we can just return current node dot element. Now at you're going to pass in the index and the element. And add, remember, you always add to the end of the linked list. But in add at, you can add in the middle of the list. So just like add, we're going to create a new node with the element we pass in. And the current node is going to equal head. We always start at the beginning. We need to keep track of the previous node. And the current index is going to equal 0. So if index is more than length, that means we've passed in an index that's way bigger than the actual length of the linked list. So we cannot add at that index and we return false. If index equals 0, that means we're trying to add the element to the head node. So we'll set node.next. Remember, node is a node that we just passed in. So the next element is now going to be the current node, which would be the current head node. And then we just set the head to equal the node that we passed in. Else, we don't want the index to be the head node. While current index is less than index, we're going to go through each index until we find the correct index. So current index increment, we're going to set the previous node to equal the current node because we want to keep track of the previous node. The current node is going to equal current node.next. We're going to keep going through this while loop until we find the correct node. So if we want to add a node as index 1 or the second node on the list, once we get to that index, we're going to set node.next equal the current node. So remember, node.next is the node we passed in, and we're going to set that to equal the current node, which would be this index right here. Then we have to set previous node.next to equal the node that we're passing in. And then we just increment the length. And the last function I'm going to talk about is remove at. Now remove at and add at are very similar. A lot of the lines are the same, except we're not going to create a new node. The current node is going to be the head. We need a previous node. The current index is going to be 0. Here is a slightly different thing. If the index is less than 0, or if the index is more than or equal to length, return null. So we cannot remove a negative index, and we cannot remove an index greater than the length of the list. If index equals 0, we're trying to remove the head node. So we just set the head node to equal the current node.next. So instead of the head pointer pointing to this node right here, the head pointer is going to point to the next node right here. Else, this part is just like the add at. We're just going to keep going through each element on the list, and once we find the element we want to remove, like let's say we're removing this second element at index 1, we're going to set previous node.next to equal current node.next. We're going to set the previous node.next, or this link is going to point to whatever was in the link to the current node. Or so this link is going to point to now this node right here. And we're going to completely take out this one. And then we're going to do length minus minus and return the node that we're removing. And now we're just going to quickly show an example of using the linked list. We're going to call the linked list conga because a linked list is kind of like a conga line. And let me bring up the console. So we're going to create this new linked list. We're going to add some items: kitten, puppy, dog, cat, fish. We're going to show the size. We're going to remove the third item on the list. So we'll run that. And see, we're going to remove cat. Now let's copy this. We're going to do element at. Then we'll try index at. And for the element, we're going to put puppy. Index of. So we remove cat. Now we check the new element at 3, which is going to be fish. And the index of puppy is going to be 1. Kitten would be 0. Puppy is 1. And the size is 4. Well, that's the linked list.